Alrighty, welcome everyone to session 3 of our water, wastewater, and housing series. This is the final session. It's perhaps one of our more eclectic sessions, but loosely focused on non-municipal water and wastewater options. And we'll be looking at a mix of systems from different angles, kind of doing some big picture stuff, as well as getting into some more technical details. We'll have some specific case studies we're looking at, and hopefully there'll be something of interest for everyone. As we're getting started, I invite folks to put your name in the chat, and if you want to include any associations, whether you're here related to work or volunteering or just as an interested community member, feel free to pop those in. I'm Ellen Hender. I'm with Vital Communities. I'm the Housing and Transportation Program Manager. We're running this series because water and wastewater have been a more and more common theme that comes up as we're talking about housing. So it's been great to put this series together. We've been able to kind of bring a mix of perspectives, share some concrete examples of successes and challenges, share some resources, have some good discussion, and we hope that there's something for everyone. So to that end, we jump over to our agenda. We have a great slate of speakers today. We have Sarah Marchant with ROC, New Hampshire. We have Alex Torpey with Rethink Local, Cathy Conway with Horizons Engineering, Dale McConkey and Ted Deers with New Hampshire Department of Environmental Services, and Bruce Douglas, who's been here for all three. Thank you. Wrapping us up with the Vermont Department of Environmental Conservation. And so a couple reminders before we move to our content. Ask that folks stay muted until we get to the Q&A so we can hear our speakers clearly. We'll save questions for the end, but do feel free to pop those into the chat at any time and we can circle back to them. If there's questions we don't get to, we'll do our best to follow up after. And as noted, this is being recorded, and this recording, as well as the previous two sessions, will be available. We'll try to get those up by the end of the week. So on that note, I'm going to hand it over to Sarah Marchant.
Thank you, Ellen. So I'm Sarah Marchant with the New Hampshire Community Loan Fund. And quickly just give you an intro into what we are and how we're kind of going to be a big picture look at some of these things today, because some of the colleagues on this Zoom call will be able to really dive into some great details as well. So at the New Hampshire Community Loan Fund, we are neighbors helping neighbors. We provide capital to people who are traditionally left out of capital markets. And one of the big areas we do this is naturally occurring affordable home ownership. And what is naturally occurring home ownership? Essentially, it looks a lot like manufactured housing. And why is that affordable? Because for homes to be naturally occurring affordable, they need to have smaller lots, they need to have less roads and shared systems. And so that's kind of what I'm here to talk to you about today. Switch sides, please. Great. So just to level set, what is a manufactured home? Manufactured homes are defined by state law in both in New Hampshire and Vermont. But most importantly, they are regulated by the HUD code, so the Housing and Urban Development for the U.S. Department of Housing and Urban Development. And this code was mostly recently updated in 2025. It is incredibly stringent. It requires some very high-level building standards, and the newest code requires very significant energy efficiency and Energy Star or better standards. Manufactured homes are not mobile. Once they are placed on a lot, the wheels and axles are cut off and they're permanently affixed to a foundation. And the homeowners own the home. In some cases, they own the land, and in some cases, they don't.
Occupied by the finance.
Okay.
If folks can make sure to be muted, thank you.
Next slide, please. So resident-owned communities is a type of community that was pioneered by the community loan system almost 40 years ago in New Hampshire. And about 20 years ago, we spun off a national brand of it called ROC USA. And in New Hampshire, it's under the ROC-NH. ROC stands for resident-owned communities. Essentially, this is when a manufactured home community comes up for sale for a private owner. The residents have the opportunity within 60 days to form a not-for-profit cooperative if they so choose, and then to submit a matching offer to purchase the park. What that means is they already all own their own homes. What that means is that they now own all the land and infrastructure, water, wastewater, stormwater, all those systems within the park, and they're responsible forevermore for their upgrade, maintenance, and upkeep going forward. Next slide, please. So how we work with ROC specifically is really based around making sure that these communities can be permanently sustainable and that they have high quality systems to support the homeowners that live there. These communities are run by boards of directors. They're kind of like little municipalities, right? They have annual elections, they have an annual budget, and they have a capital improvements plan. That is fed through the purchase process. We provide pre-development loans that are forgivable if they choose not to move forward, to bring engineers in, like some on this call today. And they work with an engineering firm to really go through their entire community and get a full property conditions report, just like a building inspection when you're going to go for your home, but a deep dive into these systems. Property conditions reports help the community to understand the status of their water and wastewater system and what might have to be an emergency repair versus what might be something that they can start planning for repairs of in the long run through a CIP process. We come in to support them through bringing in partners, some that you see on this call, like New Hampshire DES, USDA, this Community Development Finance Authority for CDBG funds, and others to help them bring in grants and other funding sources to pay for the big improvements needed on some of these systems. We connect them with engineers for system upgrades and replacements and to help them fully understand the infrastructure they're responsible for, and to assist in capital improvement plans that so they can be putting money away year over year to help maintain these systems. We provide coaching for all of that and the project planning, grant funding, and we can help people through design, bid, and construction. Next slide. So the systems in resident-owned communities are largely some have municipal sewer systems, right? When you think about the closer density, the number of homes per acre, they do not set themselves up well for a traditional 1 to 2 acre lot that has an individual well and an individual septic system, which includes a leach field, right, and tank. They just don't, there isn't enough space to have high quality water and wastewater systems for that. So how do you really provide exactly what you need to protect the environment and have high quality systems in a much more dense environment? And these are great examples we can learn from. So there are municipal systems in many, but over half of our communities have a private type wastewater systems. And there is no typical private wastewater system. Your more traditional septic system might be having a single tank and a single leach field for a home. That isn't very common in these systems. It happens sometimes. It isn't super common. What you see more often is what's in this picture, which is different configurations of cluster systems or shared wastewater systems. And so that includes each home having a tank, and then it goes to a shared leach field system, which you can see here. And I think some of the engineers will get into a lot more detail later, so I'll keep mine high level. But that allows you to have significant number of homes in a smaller area sharing one infrastructure, also overall reducing costs and being able to maintain shared systems instead of a bunch of individual systems. In any given community, there can be one giant leach field or a whole bunch of smaller ones, 6 or 7 throughout the community. It depends on how it was originally constructed and what's the best way to serve that community today under today's regulations and approvals. For water systems, I'll just touch on that really quick. Again, some have a municipal water system, but a lot also have private well systems, which can be one or more wells that are also connected through a distribution system to the community. And those are heavily regulated by New Hampshire DES as private water systems, just like your municipal system would be. They not only are responsible for replacing and maintaining all the water lines, but they're also responsible for regular testing and to make sure that there's quality water being brought through the system. And the next slide is just some examples of what we're talking about. So here's 4 different communities that we have recently worked with on improvements to either water or wastewater or both systems. Fox Hill in Franconia is 33 homes. We helped them secure $100,000 through ARPA to offset the cost of a wastewater system upgrades, specifically to replace the tanks because they had old steel and concrete septic tanks that were deteriorating and also aren't to current code. And so they have all new tanks, and that project was completed at the end of last year. And Mascoma Valley in Canaan, New Hampshire, we worked with them to help secure $1 million through ARPA for a whole system, a whole septic system or wastewater system replacement, and then almost $1 million to upgrade their water distribution system. The septic work there is currently with DES and out for environmental review, and the project will be going out to bid soon, and it will be completed before June of 2026. So these are important projects that have to move quickly. Catamount Hill is almost $1 million for leach field replacement. That is under construction. It will be done this summer. And Bunker Lane Condominium has quite the stack. Talk about all the partners, some who are on this call, but CDBG funding, USDA RD funding, and ARPA funding for a total of $2.6 million in replacement dollars. The design of the water system is currently underway, while the septic system has been designed, went out for bid, only got 1 bid that was above the amount of money they have. So we're working again with DES, the board of directors and engineers to figure out what's the next step to make sure that those systems get improved. So it's a pretty amazing system to help support these naturally occurring affordable home ownership in a high density areas to make sure that these systems are maintained, but also to make sure that these kind of housing options remain viable and provide a really key source of affordable home ownership in New Hampshire and Vermont. You have ROCs too. That's it.
Great, thank you, Sarah. I think really helpful just seeing these examples too, and like, the cost involved in this is really substantial, and it takes a lot of partners and different entities to make these happen. So great examples, thank you. We are now going to go over to Alex Torpey. I'll hand it over to you, Alex.
Thank you, Ellen. And just want to say that was really interesting hearing about Sarah. And I love the idea of like sort of small mini local democracies existing in some of these housing projects. And that just spoke to me in many ways. So just wanted to say that's pretty great. And so my name is Alex Torpey. I am the founder, president of Rethink Local. And my coming into this topic a little bit is actually, I'm coming to you from the house that I am currently midway building in the Upper Valley, and came to this not from my prior role as a town manager in Hanover or other towns in New Jersey where I'm from, where actually all the towns in New Jersey, 100% of our residents were on municipal water and sewer systems. And so I didn't have a ton of exposure to that until coming to the Upper Valley. And I didn't really have a ton of exposure to that until I started building my own house in a rural area with no water or wastewater. And so I had some questions about some of that. I had reached out to one of the state reps in the area, Monique Priestley. She connected me to folks at the state, and Bruce is on the call, and his colleagues at DEC, Brian and David, just had a really enlightening and interesting conversation about some of these things that I have also worked on with some of the local stakeholders. So if you want to move to the next slide, Rethink Local is this is a Vermont benefit corporation that's partnered with a 501c3, the Rethink Local Foundation. And so it's founded by a couple town managers in the Upper Valley. And we produce best practices, started a podcast recently, and do technical advising for nonprofits and local governments. And so after sort of touching some of this experience on a personal level, started chatting with other town managers and town administrators in the Upper Valley, private developers, folks at the regional planning commissions, what were they kind of seeing out there in rural areas with wastewater regulations. And if you want to move on to the next slide, there's kind of a couple different ways to maybe think about things in broad terms. And I think this applies to this topic, but it's maybe a helpful mental model for thinking about the sort of cycle of change to regulations and how each of us, all the different stakeholders that are involved in these things, sort of experience those things and the kind of feedback loops. And there's kind of these three different levels that are not perfect, but again, I think a good kind of mental model: this legislative level, administrative level, and informational. And so if you want to move to the next slide, you can think about these also in sort of time lengths. And so a legislative level is really thinking about, of course, legislative changes. What are things that can only be done at the legislative level that could be based on feedback, based on changing dynamics, changing needs. Those are not things that happen quickly. And maybe some would argue that's a good thing built into our government in the US, is that those legislative changes could take, we're maybe thinking 3 to 5 years. The next level down in thinking about, and this applies to, government at any level, including the local level as well. The administrative level, what are things that you can do within the constraints that are set by your legislative body, whether that be town meeting or whether that be the state legislature? Where do you have discretion within those constraints? And then the sort of low-hanging fruit level is informational. And really what that means is, especially, how do the stakeholders and how do the public interact with the rules that are in place? What is their access to knowledge? And are they sort of navigating out there in a way that is actually based on what the rules actually are? Of course, in my time in local government, it is not infrequent to find that people may be running up against an issue or what they perceive as an issue, only for them to come to a select board meeting or to reach out to a municipal official and ask a question, and they actually learn something new about the way the process worked. And that certainly happened when I talked to Bruce and Brian and Dave at DEC, learned a little bit on my end as well. And so over the last couple months, since that initial conversation where folks were really open to some of the feedback, some of the experiences of people out working on this, whether on the sort of personal level or the town managers that are seeing this on the municipal side, or private developers that have a slightly different set of kind of priorities that they're looking at versus a kind of single family homeowner in a rural area. And there's been a couple meetings with some town managers and town administrators in the Upper Valley and kind of beyond, and a couple other stakeholders. And so wanted to basically throw out a couple of those ideas on the next slide, and then basically open that to, if there's anybody who's watching, and there's a lot of people from some great organizations that are watching this right now, and I'm sure more will watch the recording. And so if there are ideas that people have of collaborations or partnerships that any of us can help facilitate, would be really interested in hearing from you. So I'll go through a couple of these bullet points. These are just kind of ideas that local stakeholders that I've talked to, and I'm not promising this is statistically representative of all local stakeholders in the Upper Valley or New Hampshire and Vermont, but just a couple food for thought sort of ideas. And that if anything sort of speaks to anybody or any organization, please feel free to reach out, because we'd love to kind of try to hit a couple of these different levels. Are there things that we can do to provide more information? I'll show an example of that when I get to the next slide, but not quite yet. And so just a couple ideas in each of these three different kind of tiers, these long-term, medium-term, and short-term, or legislative, administrative, informational. Legislative could be something along the lines of thinking about ways to incentivize less use of our natural resources in the long term. Does the law do that? I think often, and I've certainly found in my experience as a town manager, that often the laws that we have in place and the rules don't incentivize the behaviors that we want to see, but are trying to protect against the behaviors we don't want to see. And those are two very different sort of frameworks when writing legislation. are there opportunities to allow even more alternative or innovative technologies or solutions? This is something that there are a ton of on the DEC's website already that have already been approved. But are there opportunities for more? Are there examples from what other states are doing? Things of that nature. Those are things that might be legislative changes in the long term. And then one of the things that I think Vermont especially, although actually I guess Vermont and New Hampshire both, is something that I've been sort of enjoying since moving up here, is the kind of interest and commitment to DIY culture. And I think that's something that, as supply chains become a little more wobbly, Vermont has talked about right to repair legislation. Personally, I just think those things are really wonderful. And are there opportunities, and there may not be, but there may be opportunities, are there things that can be done at a legislative level that make wastewater systems not just continue to be, hold the line on all of the important environmental kind of constraints, but also are there things that we can do to allow people to take, more firsthand ownership of the home that they want to build? Are there ways that don't require as much technical knowledge or as much heavy machinery? Are there things that we can do to not just reduce the cost, but allow people the opportunity to be really involved in every single facet of designing and building their home if they want to be, which is, of course, not going to be everybody. The next is on the administrative level. Are there ways, I think we all know that in Vermont, and I'm sure others, and Bruce will speak to this, much better than I can. But you have to contract with a licensed designer, an engineer, to design your system and to have that permitted. And are there opportunities to make sure that the folks that are providing those services are up to date on all of the most recent changes? As far as I can tell, there are not enough licensed designers out there, and they're all busy. And are there ways that we can make sure that they're able to stay up to date on all the changes that might be happening legislatively or administratively? Second bullet point is the same around the sort of innovative alternative solutions. And then the third bullet point, which I think is really interesting and wanted to spend just an extra moment on, is market incentives. One of my favorite sort of types of solutions in government, and something that tried to do in the towns that I've worked in the past, is, are there really small changes that governments can make? So like a good local example would be, okay, we want to improve a local housing market or a local rental market. All of the code violations of any landowner are all public documents, but most of those public documents are sitting in a file cabinet in a municipal building. So if you're a renter and you're looking at properties, you don't necessarily have access to easy information about, is this landlord had lots of problems with code, property maintenance, fire safety issues in the past. You don't have access to that, though all that information exists. And it's all public information. It's just not usually in a format that people can find. So on a local government level, putting those things online or making those available in a machine readable format, and then letting somebody else do something with that. So it's not necessarily taxpayer funded or the responsibility of the government to solve the issue, but it's taking the existing data and putting it out there in a format that allows other people to do something with it. And so, for example, with licensed designers, one of the ideas, and this is something that some of us have been talking about with vendors that do contracting with local governments, it's hard to find, it's very relationship based, but a lot of folks are leaving and retiring, and there's a drop off of knowledge. How do we know if a potential vendor is a good vendor? How do we know if a licensed designer is a good one? The DEC, on the state website, there's a long list of all the licensed designers, I believe, in the state. And I imagine New Hampshire has something similar. Are there ways to allow people to have someone port that into a database that allows ratings or reviews or feedback about projects or examples of work, or if someone is familiar with an innovative or sustainable system or a small scale system for someone who wants to really lead a more minimalist life and wants their wastewater system to be part of that. And right now that information is not really out there. It's sort of half out there. And so that was one of the ideas that's been batted around a little bit. Are there ways to put that out there more and not necessarily put a greater burden on the state to manage more stuff, but just put things out there that others might be able to then use? And then on an informational level, and I think part of what was so cool about folks at DEC with some of the questions that a couple of us had was a real interest in providing more public information about some of the things that could empower a homeowner to help ask better questions of their licensed designer, to make sure that they are familiar with all of the options that are out there. It's like if you're going to the doctor, you know, in an ideal world, you are able to offer some of your own analysis of what's happening so you can kind of make your best decisions. And so, for example, one of the ideas that we've talked about developing is a checklist for a homeowner that they can literally print out. And when they're talking to an engineer about they can ask a bunch of specific questions that a handful of stakeholders might put together, and that might allow someone to ask better questions and find a designer that really meets what they're looking for. And then the other piece is really local partnerships and collaborations. There is a huge, obviously, need to unlock more affordable housing out there, and we only have a finite number of things that we can turn dials on. And if there's an opportunity to help people design systems that are lower cost within the existing rules and within the existing legislation, that's an amazing thing. You know, even a couple $1,000 savings for someone might make or break a housing project, or might enable them to put that money towards something else. Now maybe they can build a greenhouse and they can grow some of their own food. And so all of these pieces are, of course, kind of connected. So if we want to go to the next slide, I think I got a little ahead of myself. Oh, well, yeah. So one point is just these are sort of cycles that helping improve the public engagement piece, making sure people have the most up-to-date information, is helpful in building momentum and support if there are any additional things that we want to change at an administrative level or at a legislative level. Tapping into those town managers, town administrators, private developers, regional planning commissions, organizations like Vital Community. There's so many different organizations out there. And are we sort of building momentum and building support so that if there is some change needed, those folks are ready to send letters to their legislators or to call the governor's office in either state and say, hey, all of us, this group of 25 different stakeholders that represents these different interests, we all share these 3 different priorities that we'd like to see in the next legislative session. And so I think it's just important on the government side, always remembering that the more that we can inform people, the more that we can bring them into the process, the better allies they'll be in the future as well. So the next slide. Yeah, I think so I sort of mentioned this already. What's shown here is a little bit of a graphic of an idea that we've been talking about, designing a brochure for people with maybe some questions or ideas that they can, again, help homeowners have more information so that they can ask better questions, so they can make sure the systems that they're designing are not overbuilt for what they need, but are built exactly for what their needs are in their building project on their property. And so I kind of mentioned each of those 3 different examples already. And as we've been sort of working on this a little bit, the ideas shifted a little bit to maybe producing as a first step that checklist. And then maybe in the longer term, building some support from different local stakeholders to get some grant money to take the enormous amount of amazing technical information that's on each of the New Hampshire and Vermont state websites, but is very hard to read through as a layperson. Unless you have an engineering background, some of that is very hard to make sense of. And some people immediately, you pull up a document and it's a 250-page PDF. And I feel like it's okay. I can't even I don't know where to start. And so could we get a couple stakeholders together, get a little bit of grant money, hire a graphic designer, and distill some of that super technical information down to something that's more accessible and more visual so that homeowners can access even more information that they can use to work with their designers to build a system that really works for them, and or to raise feedback if they're running into issues. So that's basically what I wanted to talk about. And if you want to go on to the next slide, just for folks, if anything that I've mentioned here sort of speaks to anybody, you say, oh yeah, this is an issue that we've talked about in our organization or in our town, and you'd like to be a partner on any of the kind of things that I've mentioned, please feel free to reach out to me with my email down there, alex@rethinklocal.us. And just to want to appreciate and thank the folks, especially at the state, who have just been open to really insightful and thorough conversations about this stuff, and also appreciate Vital Communities for hosting these.
Thank you, Alex. I think, such a great mix of ideas in there, and excited to see where the conversation goes, what else comes from it. But thanks for kind of offering that angle on this. I'm going to hand it over. I mean, one thing you mentioned was our engineers. So we're going to hand it over to an engineer, to Cathy. Over to you.
Hey, everyone. Thank you for coming and taking the time out of your busy day to listen to us talk about wastewater and water infrastructure. Oftentimes it's something people want to forget about, put the pipe in the ground and not think about it. But it's important for all of us to kind of understand it a little bit better. And so I'm going to just share with you some of the processes we go through for improvements, as well as a couple of case studies. So next slide, please. And Sarah already talked about this a little bit, but before we can go in and develop a solution, we have to understand what's going on with the site. And there's several different ways that we can do that. And one of those is a property condition report. If it's an existing site, we look at the existing utilities. What kind of condition are they in? Are they in great condition? Are they 50 years old and falling apart? And then we develop some recommended improvements, an opinion of cost, and a budget for O&M. And then there's, next slide, please. Another way of identifying these existing conditions, a little more detailed, is the preliminary engineering report. And again, whether you've got an existing site with existing infrastructure that's giving you some maintenance issues, or you're looking to develop a new site, it's always important to understand what the soils are like, what the elevations are like, because all of that is important in the costing and development of systems. A preliminary engineering report kind of takes things a step further beyond the property condition report. We look at the need for the project. Why are we doing this project? Why do we need to do this project? Do you have poor water quality? Do you have failed leach fields? We also consider the alternatives. As Alex talked about, we want to find the alternative that best matches with your needs. Each site is different. Each entity is a little different. And so we want to make sure that we're considering all the alternatives that might make sense for your community. Just because municipal water might be 2 miles away, maybe that still might be the best alternative. And this preliminary engineering report gives us that opportunity to look at all those alternatives, come up with the recommendation, and again, the cost and the operating budget. Next slide, please. And then the other way to kind of identify conditions, this one's a little more involved, and it is called the asset management planning, right? These assets, these water and sewer systems are valuable. We've got, we look at the risk of failure, the age, and the importance of that component of the system. We still do the same basics. Doesn't matter which process we're taking. We still look at the utilities and the condition. Here we develop a capital improvement plan and the asset management strategy, as well as financial is always important. These are big investments for people. Next slide, please. And then I wanted to spend a little bit of time on a couple of case studies. This particular project, Lee Oak Mobile Home Park in Barrington, is a ROC-NH project that Sarah mentioned, some of the other projects. When we got involved in this project, the very first thing we did was a property condition report so that we could understand what was going on with the infrastructure. As part of that, surveys are completed by each resident, so we get to know, my water has a metallic taste. It's leaving rust stains on my fixtures. Those kinds of things are important for us to know. This particular property has about 44 acres. 77 house sites. It has what's called a community public water system. It had a single dug well, which was too close to leach fields and too close to wetlands. So you started having some surface water influencing, didn't meet any of the regulations that it needed to meet. The distribution main was an 1.5 quarter to 3 inch plastic pipe. Some of that was undersized. The storage, there was no atmospheric storage, just pressure storage. So that property condition report gave us the background so that we could understand what was going on with this system and then make some recommendations for improvements. Next slide. And so basically what we wound up doing for Leo is a new system, a whole new system. The water main, this picture on the left-hand side is we replaced that undersized water main with 4-inch water main, and we added gate valves because oftentimes some of these older systems you couldn't isolate it. So if you had a break, everybody was out of water, which creates issues for the folks. We also did a new pump station. The picture up in the upper right-hand corner shows that pump station under construction. And again, looking at some alternative ways to do things, we actually used concrete tanks to be the foundation of this building. So that provides the atmospheric storage that we need. So we've got 20,000 gallons of storage underneath this building. And within the building, we have a small pressure tank. So again, those are, in the past, we would bury these big steel tanks with the tank sticking in through the foundation. But again, this is a way where we're kind of trying to value engineer these projects for these communities. And then the last piece of this project was the development of a new well. We needed to replace that source that was not great. Regulations require that they should have 2 wells. And so we're going to keep the other one online as a backup. But this was the work that we had done on the water system for this park. And it was roughly a $2.5 million project that had funding from ARPA, CDBG, Drinking Water SRF, and the Drinking Water Groundwater Trust Fund. So it was, a package of funding sources that was able to make this happen for this community. Next slide. Okay, I thought I had a wastewater slide in there. I'm sorry. So that we also, for this project, as part of that $2.5 million project, there were some of the leach fields that needed to be replaced. And so what we did is we replaced about 7 of the systems that were in the worst condition. And those, as Sarah talked about, were community systems. They served 1 or 2 homes so that we could fit them in the tight area. So this slide is another example of another mobile home park that we worked with. This one is in Hill, New Hampshire. It has 20 homes on it. And this particular system is connected to the Hill Waterworks municipal water system. It's got 2-inch diameter pipe. The pipe is about 40 years old, but seems to be holding up pretty well. But the issues here were the wastewater systems. Each home had its own system, and the soils were generally sandy and good soils, but the systems have been in for 40 plus 50 years, and maintenance wasn't always done. People didn't understand the need to pump the tanks every couple of years, so the system started in failure. Maybe they started getting mounding of water on them, and tanks, septic tanks are now larger than they were 40 years ago. So there were a lot of reasons that these systems started to fail. Next slide. And so our initial plan to resolve the issue here was, you can see in the upper part of this picture, that's where we were looking at installing community leach fields. This facility had some open area that we could utilize. And so what we thought is that instead of each of the homes down around that loop road at the bottom of this photo having their own systems, we would put in sewer main in the street, bring it to a pump station down at the low point at the bottom of that loop, and then pump it up into this community leach field. And one of the reasons that you can see multiple fields in this leach field is when you get to the larger systems, sometimes it's harder to fit them into an area because of nitrate setbacks. So it's kind of like putting a puzzle piece together. How do you fit these in the best way, maintain nitrate setbacks on the property if you can't get a down gradient easement, different things like that. So this was our plan A. And we developed this plan with the support from the homeowners, a couple local contractors, DES, and then we did an estimate. And it was considerably more money than they had available. So we then had to go to Plan B, which is the next slide. Whoops. I'm not sure what happened to my wastewater slides, but anyway, so Plan B was, if we could go just back for a minute, Ellen, if you don't mind. Okay. So Plan B was down in this lower area where the road is in the existing mobile homes. There were about 5 units that had the worst systems. So what we're doing now is we're in the process of designing a system for 3 of those units. Down at the bottom of the loop, we're designing a system for 1 unit and then another one for further up in the loop. And so we will put this project out to bid and hopefully have enough funds to maybe do a couple of more change order with the contractor and do a couple more systems. From a maintenance perspective, we always prefer these community systems because there's 2 septic tanks to maintain. Easy to remember, I'm pumping a tank every year versus having multiple tanks, multiple systems, limiting what people can do adjacent to their home and that kind of thing. But again, because we're not running sewer down the road and doing a pump station up to the available land, this alternative is going to be less expensive. And so it's an alternative that is what we're designing and will bid later in this summer for them. And so just to kind of summarize, this is not a one-size-fits-all solution. Each property has its own conditions. Is the soil good? Do you have wetlands that you need to be a certain distance away from? If you've got a beautiful sandy soil, you're golden as far as leach fields are concerned because the perk rate is good. It's a good setup for a nice longevity of a leach field. In terms of water systems, oftentimes we find that the systems that were installed in the 70s maybe didn't have a lot of oversight. Distribution pipes were put in and didn't have proper backfill, so rocks were put on them. So now the property owners are often repairing those systems. The other thing here in New Hampshire, we've got a lot of elevation change, a lot of mountains, right? So sometimes these water systems have multiple pressure zones and it just complicates the operation of them because it doesn't matter whether you've got a system for 20 homes or 120 homes, you've still got to, as Sarah mentioned, Meet the operational requirements, provide water quality samples, make sure you've got a licensed operator, all those kinds of things. So whether you're needing to retrofit an existing system or you're looking at the development of a new property and a new system, kind of get the lay of the land. Think about what the property looks like, what the soils are like, what the elevations are like, so you can start thinking about how costly some of these infrastructure developments are. So I think that I will stop there. And I know questions are later. I have the one next slide about questions, but yeah, thank you.
Thank you, Cathy. Sorry for a couple of the missing slides. I'm not sure what
That's
happened.
fine.
Yeah, really helpful to just kind of understand the kind of whole thought process and evaluation that happens as you think about designing these systems, and then sometimes how the cost means you have to go with a different plan. And yeah, really helpful to kind of hear how that all plays out. All right, we are going to go over to Dale McConkey and Ted Deers with New Hampshire Department of Environmental Services. Really glad that you both could join us today. I've been plugging your existence the last couple sessions, so glad to have you here. I'll let you take over.
Thank you, Ellen. Also, it's great having everyone else here. Also fun to learn about Vermont and how other states kind of navigate through all of this. And I guess it's nice to also see New Hampshire doing some of the right things. So my name's Dale McConkey. I'm a New Hampshire Department of Environmental Resources, Land Resource Management Specialist. Also, before I took this job, I was permitted New Hampshire designer, installer, as well as a licensed evaluator. And it's just important to note in New Hampshire, we are permitted professionals through NHDES. I know a lot of states are licensed. So that's just one thing that is kind of a fun little fact of the state of New Hampshire. I'm also joined here with Ted, who's going to introduce.
Hey there, everybody. I'm Ted Deers. I'm the Assistant Director of the Water Division. So the Water Division incorporates all of the different water programs within the department. So we, everything from drinking water, wastewater, lakes and rivers, beaches, shellfish, you name it, we pretty much got it. It's got water. So it's great to be here. Dale's gonna do the heavy lifting. I have just a couple slides at the end, and then I'll be here for questions if they come up across other aspects of water and wastewater.
Thank you, Ted. So we're going to go over New Hampshire wastewater permitting overview and pretty much what happens if you can't connect to a municipal sewer. So one of the first things you want to ask yourself is, do you have water and sewer and the availability of it? Just because a pipe runs by your property doesn't always mean that you can connect to it. So it's good to check with your local town or city to confirm whether a sewer hookup is feasible. Just because an infrastructure is nearby doesn't guarantee access. And if sewer isn't available, then the Subsurface Systems Bureau, or the SSB, will be the permitting authority. Next slide. So the Subsurface Systems Bureau, or SSB, handles septic system permitting, where we review and the approval of residential and commercial septic designs. And then they also handle subdivision review, which is lot layout and septic feasibility for subdivisions under 5 acres. So if you have any questions or kind of need guidance, a good resource is to call the Subsurface System Bureau. Reviewer of the day, which I have listed here, 603-271-3501. And then also, if you scan that QR code, that'll bring you to the NHDES septic or subsurface website, which has a lot more additional information and contact information. So the SSB issued 2 types of approvals. One is a construction approval and the other is an operational approval. The construction approval is issued after a septic design is submitted by an ISDS permitted designer, which then goes to Concord and is reviewed by plan review staff here. And once that is all good, they give you approval for 4 years. Then you're given the operational approval after the design's been approved and a permitted New Hampshire installer, septic installer, installs the septic, and then an NHDES regional inspector comes out and confirms that everything was installed per the plan, and then you are issued the operational approval. So the operational approval is valid until a change of use, flow, or other qualifying changes to the property occur. So it's kind of important to note, if the property has separate leach fields and septic tanks, then an additional construction operational approval may be required. Next slide. So early consideration and planning is, you should kind of plan the whole development in the early phases just to avoid future complications or expansion issues that may arise. So some things to consider are setbacks, account for site restrictions, required distances when placing system components, and Cathy kind of hit on it, like, wetlands and other things like that have their own setbacks that you should be, knowledgeable in to make sure, you're going to be able to withhold those. Other key things are the soil that affect the sizing of the system, or the soil type, and the percolation rate. And if you guys don't know what percolation rate means, that's basically determining how fast water can get through the soil, and that's determined in minutes per inch. So a faster perk equals smaller leach field, while a slower perk will give you a larger leach field. And then the calculated flow, which is the total gallons per day, or GPDs, based on number of bedrooms or use type. And then same kind of thing about, if you have multiple, unless it's a shared system, each septic tank and leach field may require its own construction operational approval. So the calculated flow for residents is primarily based on the number of bedrooms in the home. So for 2 bedrooms, it's 300 gallons per day, 3 bedrooms, 450. Then each additional bedroom adds 150 gallons per day, though the minimum design flow is 300 gallons per day, even in small homes. So studio apartments, 1-bedroom apartments are calculated at 225 gallons per day. So I have shown here a table 1008-1 from the ENVWQ 1000, which is our administrative rules. So if you search that or click on the link, it'll bring you to our administrative rule book that is, well, in my following slides, I have additional tables and stuff, but that's really the main kind of bulk of our rules and regulations as far as developing in New Hampshire. So to determine your minimum lot size is determined by your soil type, property slope, and the number of bedrooms. So if you look at the table below, a 2-bedroom home on a level flat piece of property with a group 1 soil, and a group 1 soil is considered, excessively drained soils. So like Cathy was saying, sandy soils where the water can really get through it quickly, versus a group 5 is worse. So on a 2-bedroom home on a level flat piece of land with group 1 soils, the minimum lot size is 1 acre, while that same home on a level lot with group 5 soils, you're going to need 3 acres to build. So same kind of thing with the key factors, poor soil, you need more of a lot size, bigger lot size, more bedrooms, larger required lot size, and steeper slopes is also a larger required lot size. So a tool that you can use is the online web soil survey, and you can find that by just searching web soil survey in Google or whatever search engine you prefer. But if you search that, it'll bring you to this website, and then you click on the Start WSS as well as scan the QR code. But it is important to note that in using this tool, it's not a guarantee of what actually is on site for soils. Should just be used as a tool to kind of gauge or give you an idea of what potentially is there. So if you go to that website, it'll kind of bring up the map, and then you can zoom in and really kind of zone into just your property, and then you create this area of interest around it. And then from there, it'll break it out and tell you, the average slopes, just general soil characteristics, as well as the drainage class and kind of what you might see on site there. But again, this could vary from what actually is being seen. So when you get a designer to go out there and they dig a test pit, it could vary from what is being shown on this website, but it's a very handy tool. And if you use that in combination of some of our other tables and stuff in our administrative rules, it can give you a pretty good idea of, the lot size you need and other things. So we calculate the leach field sizing. It's based on your calculated daily design flow as well as the percolation rate of the soil. So if you look at this table here, a 2-bedroom house with a 2-minute perk rate would require a 400 square foot stone and pipe leach field. In that same size home with a 14-minute perk rate, 637 square feet of stone and pipe in order to do it. So a slower perk rate, larger leach field. And probably you guys may have discussed on your other ones, alternate technologies. So like in New Hampshire, we have the Presbys and Infiltrator and a few other systems. So those are approved alternative technologies. So those have their own set of rules as far as leach field sizing and how those are calculated. So then everything has its own kind of distance that has to be required. So in table 1008-2, we have the features as well as the components. So a septic tank, the leach field bed, and the sewer line could all have different setbacks to certain things. They might not all be the same. So if you think of like a water line, a pressure water line, the septic tank's 10 feet away, bed has to be 25 and the sewer line 10. So just if you are referencing that table, to just make sure that you're looking at, the different system components. And then the final thing that kind of comes into play with planning is the well radius. So the way we calculate the well radius is your daily sewage flow, gallons per day. So if you have a 2-bedroom house, which is 300 gallons a day, you have to maintain a 75-foot protective radius from the center of the well outwards. And so say a 6-bedroom, which then kicks you into a 900-gallon, which brings you to the next level of protection, has to be 100-foot radius. And I believe Ted's going to take over from here for a few.
Just in the nick of time. So I'm going to talk just really quickly about wells. And the thing about so just private wells, in terms of if you're going to drill your own well, New Hampshire really doesn't, we don't regulate those per se, but we do regulate them through the location, as Dale just talked about, like where they can end up on the lot, setbacks, things like that. We regulate, the construction, and we regulate the pump installation through the well drillers and pump installers. So we basically license them. We have a set of rules, and then they adhere to those rules. So like Alex talked about, these lists of people who are qualified to do this work, we do have those lists, and we have those for licensed septic installers and designers, as well as licensed well drillers and pump installers. And so those do exist, but I think I understand the frustration of not knowing anything about those individuals. That really is word of mouth. And I will just, having recently built a house in a small community, I will say that the local Facebook pages are awesome for finding those kinds of things out. We find some, that's how we've gotten connected with some very good contractors of different sorts. I think a lot of people are tempted, because we are a wet state, to say, hey, I got a pond, I'll just drink some of that. We highly discourage this. It's not illegal if you want to drink your own pond, but it definitely is highly discouraged, and a very good way to end up with some pretty bad diseases that are naturally occurring in the environment. The way that if you want to sort of calculate what do you think you need for a well, the average person needs about 75 gallons of water per day. You can see that that's different than what Dale was talking about in terms of how much comes out. And that's because you're talking about multiple people. These are totally different measurements. These are bedrooms versus people. And so this is a really an interesting, I think, dichotomy that gets people confused a little bit in terms of the different regulations for water and wastewater. But again, these are recommendations. You can actually undersize your well for your house if you think that you want to really conserve. Alex talked about how do you get to a place in which you can have smaller systems. We don't have truly gray water regulations in New Hampshire. So even if you were to use less water, undersize your well, you're still going to fall into the same kind of requirements that you would have to have for a wastewater system. All right, next slide, please. So we talked about that, public water supplies are certainly a more efficient way of having multiple systems together, multiple people together. We have about 2,500 public water systems in New Hampshire. And basically, you're a public water system if you're serving 15 connections or more. So if you're less than that, you may be considered a public water system if you share components or if you're shared ownership. So like some of the ROCs that we heard about earlier, those are places in which, because they're under a condo association or under the co-op, they would generally be regulated as a public water system. And then between a public water system, if you're a community water system, you end up in some different ways of how we regulate you, different levels of regulation. And I'll just say that the community water system has significant requirements because, what's more important to your safety than the water you drink? And so if you are going to go into the world of having a community water system that serves your housing, you really do have to make sure that you are applying these rules and making sure that you're safe. Lots of reporting and monitoring. That's how we keep people safe. Certified operators. This has come up a couple of times in terms of needing a certified operator. If you're going to have a community wastewater system that Cathy was talking about, you're going to have a certified operator. Certified operators are becoming very difficult to come by because not a lot of people are entering that field. So before you go down this road, you want to make sure that if you build this thing, you actually have somebody to operate it. So this sort of communication between the regulator, the developer, the owners, and then eventually how you're actually going to operate this thing. And this is one of those places in which you have a large developer hands this thing over to an HOA or a co-op, and they're hands off. And if they haven't gone through some of these questions, it's going to be challenging for that new set of owners. These are some of the problems that we've seen around the state. Well siting can be extraordinarily complex, especially for larger wells, especially in the southern part of our state, in which we have what we like to say about this, and this is the same and true with wastewater or water. Geology is destiny. If you have the right geology, you'll be able to do pretty much whatever you want and whatever size lot you want. If you don't, and a lot of the good land is already taken, you could have a lot of complications in your development. This is one of the challenges to developing public housing today. Next slide, please. And then connecting to a public water system, Dale mentioned this, I was going to mention very briefly, or wastewater system very briefly, is that there's a lot of variables that go into capacity calculations for both water and wastewater. And one of the things is that we often don't allow an individual or a new development to go directly into a force main. So oftentimes they will need a pump station, which will take them to another pump station or take them into a gravity well or something like that. And there's also limitations on the treatment side. We know that there are a lot of facilities that are really close on their effluent limits for something like biological oxygen demand or ammonia. And so adding new capacity, even if they have big pipes and big pumps and it's no problem to handle the capacity, they may actually have effluent requirements that are causing those constrictions. So this is something that has to happen if you're thinking about, if you're going to be near a public wastewater system, is you have to have early conversations with those folks to make sure that they've addressed all of those different kinds of things. And some of those aspects may be required to have design review and permitting by DES. Next slide, please. And so this is really just some of the questions. We just put this out there. I know you're going to make these available, but these are some of the questions that I would be asking if I were going to be trying to hook up to public wastewater systems. And so these are just a little checklist. Final and last slide, please. It may be that if you may be into other bureaus, and I don't know, Dale, if you want to talk about this or not, but DES has lots of different parts. There's lots of different regulations that can come in under different aspects of your development projects. So take it away, Dale.
Yep, thank you. So the Subsurface Bureau, or SSB, as we keep talking about, they handle most of the septic permits. But say if your calculated design flow is greater than 10,000 gallons per day, then the Wastewater Engineering Bureau will be involved. If you're within 250 feet of a protected shoreland or near wetlands, the Wetlands and Shoreland Bureau is going to be involved, as well as, like you talked about, water supply permits as well. Next slide. So that's just some information. I believe the slides are available, but those are, some more information on when to get them, how to get in contact with them. And that's just some final resources, but it's good to, make sure you're always working with a permitted designer or installer in New Hampshire when you start these projects. So, searching our one-stop database, you can find these professionals. You can narrow it down by county or town, actually find them. Some of them are designers and installers as well. So if you find one of those, they might be able to answer, more questions. And yeah, greatly appreciate the opportunity to be here and hope everyone found that helpful.
Thank you both, Dale and Ted. Really great kind of overview of all the things to be thinking about and different places to go for the different pieces. I'm glad that this is recorded and we'll be able to have this accessible for folks. So thank you.
Thank you.
We will hand it over to Bruce to close us out. Bruce, over to you. You're muted, Bruce, so we can't hear you yet.
Let's get the audio going. Hey, so thank you, Ellen, and thanks to all the presenters. I've learned a lot already today, so it's been very, very helpful for me. We didn't plan our presentations, and there's a lot of similarities between New Hampshire and Vermont, a lot of differences, but I think there's more similarities than there are differences in our programs. And what I'm going to just go through the process of getting a permit, but not as much about the specific requirements. And along the way, I'll provide some background and context for the regulatory requirements and talk about the landowner responsibility regarding on-site potable water supplies and wastewater systems. So I'm calling it a primer on the topic. Next, please. So we are focused on human health and the environment in Vermont as well as New Hampshire is. And these 7 bullets is the purpose, right? Summarized, but out of our rules, out of our statutory mandate that get into the purpose section of the rules, that we really are comprehensive. We want to make sure the owners have knowledge of design, operation, and maintenance. We do need to allow innovative alternative experimental technologies and protect homeowners' investment and the reliance in the private sector. One thing that's interesting, I'll say now, is that in 2007, the state of Vermont was given universal jurisdiction over potable water supplies and wastewater systems, whether it's on-site or municipal connections. And we've had a regional office program since the 70s, but basically we had a 10-acre, we call it 10-acre loophole, and if you had greater than 10 acres, you didn't need a state permit, and towns weren't required to have a permitting program for your on-site water and wastewater. So that changed in 2007. And one thing that the legislature said is you have to have innovative alternative technologies to help landowners overcome limitations in their soils that Dale alluded to with the different technologies out there. We issue most of our permits within a 30-day performance standard for a single family residence or slightly larger, and a 45-day performance standard for the moderate to large size systems. And for scale, just for reference, I'm going to be talking today about less than 6,500 gallon per day systems. So less than about 25 or so households. And all the data, we have a couple 100,000 data pieces that are in an online searchable database analogous to what New Hampshire has. Next, please. So and this was interesting. Cathy was very, very helpful. Kind of like what a typical engineering approach is to a large project is. I'm going to kind of focus on the smaller scale, more of a homeowner or small subdivision approach, which is hopefully some useful contrast. So the landowner kind of establishes what do they want to do, and then they hire a licensed designer. And the designer has to kind of take those landowners' goals and objectives and kind of get more specific relative to what's a project that they can provide, with the land available in a very conceptual sense, but also come up with the design flows as Dale explained. In New Hampshire has very specific design flows. Vermont has its own table, a couple of pages long, with our breakdown of design flows. But for residential housing, we're both using bedrooms. And we just have a different way of applying those bedrooms to come up with a design flow relative to project scope. So next slide, please. I'm going to start with water supplies and work into the wastewater, because we all need water. I mean, as Ted was saying, it's sort of, you got to have healthy, clean water. And so we need to provide that in adequate quantity and quality. And so when we're permitting, we are really focused as on our side of the river on the location, the proper siting of a well, but there's also the type of the well, whether it taps into bedrock or a confined aquifer, has a different isolation distances than if you're in a shallow or an unconfined aquifer, an aquifer that basically is more connected to activities up at or near ground level. And on the left is a dug well, which is permittable, a shallow water supply, but it has a much greater isolation zone around it. On the right is a drill rig, drilling a new bedrock well for a single family home. And one example, that's a great example of the truck being jacked up a couple of feet. It really is critical that for siting a well, it's not just getting the right isolation distances to leach field, it's where can you get a drill rig in. That they're very large pieces of equipment and have limitations on. They couldn't have necessarily gone up to the top of the hill of this property. The person wanted the best view. It's a very steep hill just off camera. So we address the quality and quantity with siting, design, construction, testing, and O&M requirements. And I'll make one point following up on the surface water sources. We do, by statute, we are required to allow surface water sources, but we limit them to expanding development. If you trigger a permit, it's only for owner-occupied homes with extensive treatment requirements. And one thing I will mention about just the jurisdiction, universal jurisdiction, essentially there was what we call a clean slate. In 2007, there was for lack of a better word, an amnesty. Whatever you had for water supply and wastewater system and the use of your building or structure that required those systems, that was not going to be a violation. Even if it was a violation in 2006, it wasn't. If you didn't have a permit, if you didn't have a permit, you can continue. If you had a permit, though, then you would need to have been in compliance with it before and after. But if you had no permit, house that was built in 1792, and who knows what's under the ground, but the water's coming in, the water's going out, that was okay. is okay. It's just that when you change that, you do a major upgrade to your water system, your wastewater system, add a bedroom, then you trigger a permit. Add an ADU in the barn, would trigger a permit. Next, please. So just and geology is key. I think I heard Ted that said that. I mean, this is Montescutney is the green fish in the middle, and you can see the Connecticut River, and New Hampshire's a little paler, but on our geologic maps we make our colors brighter on our side of the river. But basically, there's complexity, so you can't guarantee you're going to have water. You got to basically recognize there are ways of overcoming typically of a low yielding well with storage and development of the well. Next, please. And there's shallow water. And so I talked about the unconfined aquifers. They're typically in the valleys where you might have more granular, more sandy, more gravelly material. And this is the same shot we just looked at, the bedrock geology. This is called the superficial geology, which most of it is the pink, which is a glacial till, the layer on the surface of soil, sand, silt, clay, and stone that is basically not typically a great water supply in its own sake, but may locally be available for water. But it's also the building block for the soil in which the wastewater systems go. So when we need to, I think I really like the fact that Dale showed the web soil survey, because that's the highest level of planning scale mapping available. So that's the next level. You go, superficial geology, then you go to the soil surveys, then you go to the site investigation. Next slide, please. I just quickly shot this picture of different kinds of aquifers, different yields, different levels of protection. Next slide, please. And maintenance is key. You need to protect it from parking cars or any getting hit by a turning around UPS truck or whatnot. You want to prevent contamination by being cautious of what you're doing in your lawn and vicinity of the well, and what your neighbors might be doing. You want to inspect it, make sure that your well cap isn't broken, isn't loose, so critters can get into it, and just have good water use, habits and appliances, and keep your records in a safe place and using qualified professionals. Next, please. So soil-based wastewater systems. So these are very elegant solutions to a problem. I mean, they've been around for decades. Back in the 1920s is where the perk test was developed by a sanitary engineer in New York State, and Vermont did abandon the percolation test in 2023. We had it for a long time, and now we just use what we call soil morphology to determine the suitability of soil, the characteristics of the soil in place. We designed our systems based on. But we basically need to use soils and the infrastructure to get treatment and dispersal and protecting sensitive receptors, which would be drinking water supplies, groundwater, surface water. And the available components, the tools we have, one is source separation, which is not commonly used, but it's out there. It's a composting toilet that could reduce the flow to a leach field if that's what you choose. I'll get to another source separation down the list, but the septic tank is it's a very slow primary treatment tank, and what it does is it takes the floatables and the sinkables, separates those, so you have a relatively clear liquid we call effluent, septic tank effluent, that goes to the leach field. And in that slow decomposition just decreases the volume of the solids that need to get removed. This is why you don't have to pump it, except for it's on the order of years as opposed to weeks or months. Because you get that decomposition and consolidation of the solids. Different dispersal systems, how it gets spread out into the environment, and different innovative alternative technologies. One of them that's really being pioneered in Brattleboro, Vermont, is urine diversion, which we allow. Is you could basically have a urine diverting toilet, or other means of separating your urine and basically not putting the nutrients that are in urine down the drain, and with there's a company called Rich Earth Institute that pasteurizes it and uses it for agricultural purposes. We also have secondary treatment, many technologies out there, different dispersal technologies. We have new technologies of combining treatment and dispersal, and a very interesting thing that's available, processed glass aggregate. All those bottles that you recycle can get, mechanically broken up and smoothed a little bit into a very manufactured, specified size range that actually, with the right equipment, can be similar to what we call mound sand. So it really is a challenge to finding good mound sand for mounds, because a mound system, we'll get into that in a minute, but basically what Solid Waste District has gotten a permit to use their processed glass aggregate, and they haven't yet, but we're hoping to get those in place. And we wanted, addressing to get the treatment, dispersal, and protection, siting and design, construction, inspection, O&M. All those are pieces of the puzzle that need to be considered. Next, please. So you're going to see a similar theme of slides here from US EPA, but basically one thing that's interesting is note the groundwater well on the left side of this slide. So basically the source of the water, we want to site that carefully. In this case, it is uphill and sufficient distance away from the leach field. And then coming out of the house is a septic tank with ability to access it with risers. And then a distribution box also with access that goes to leach field, which is, would be crushed stone in this case, and pipe. But the goal, the size of that leach field is, as Dale talked about, is to spread out that effluent so you get the treatment in the soil before it reaches the groundwater, and you don't get excessive clogging of the system either. You get a nice equilibrium of water coming in and a little bit of a clogging layer in the bottom of the stone in this case. It just slows it down. It doesn't inhibit it from flowing through it. Next, please. So a chamber system is using the infiltrator that Dale mentioned. Plastic pipes rather than sand and gravel might be useful if you got a narrow backyard and you can't get a big dump truck back there, and you could use carry your drain field equipment out. Next, please. The mound system. This is kind of EPA's tried to adapt a little bit version, but basically it was developed in Wisconsin, the University of Wisconsin, after the governor got sick from a pathogen that he got it from a septic system contaminating a well at I think it was a county fair in the 70s. So there's a raft of information, and they studied how the treatment can be optimized in soil in specified fill, and came up with the mound system. So Vermont uses the Wisconsin mound design. It's a very simple system, low. It's the only thing additional is you're adding a pump to pressurize it to get good even distribution, and you're adding that sand to get consistent treatment and acceptance. Relatively small footprint acceptance of that system. And overall, I just want to say these systems are elegant from an engineering standpoint because they're well thought out, technically sound, but they and can be installed in a variety of settings with the design criteria, but also that they have low maintenance, and that's key to what homeowners, appreciate. They want a system that they don't have necessarily. Most homeowners don't want to have to tend it and take care of their wastewater system. Next, please. Drip is becoming very, very common. It has a lower profile. It's basically using, basically a pipe the size of my finger, and it has small orifices, about 1 to 2 feet apart, and really gets nice even distribution, and doesn't require the depth of a stone and pipe trench or chamber. Next, please. And this is the slide we've already seen, but basically multiple septic tanks can be worked in it doesn't have to be a manufactured housing community, can be a neighborhood, could be a cluster of houses. Next, please. So the specific design steps is the designer will do a site and soil evaluation, pick the area that, relative to the owner's needs of that's available for a potential leach field that's separated from the water supply on the site and neighbors' water supplies. And then there's test pits, hopefully with fewer people than 5. But basically this is a training session for our regional engineer staff. But basically they're describing that soil characteristics and coming up with depth of season high water table, and also application rates, the low, medium, and high perk rates that Dale was referring to, and looking at topography to see where the system fits in, and any other natural and cultural features you need to separate your wastewater system from. Run that by the landowner, prepare the plans and supporting information and the permit application. The landowner signs the application, provides the fee, and the designer submits it online on the landowner's behalf. Next slide, please. And so the permit's recorded, the municipal land records by the landowner. It's available to the public in an online searchable database. I wish I had a QR code. I love that. Here's a designer testing a pressure distribution system, to show even distribution. But so you need that designer involved in the installation, because they have to certify they have to stake it out, and B, they have to certify that it was installed correctly. Next slide, please. Maintenance is big. Know your permit conditions. Make sure you know what you're required to do if you're buying property or you get a permit for a property that you own. Don't drive on your wastewater system components. They're typically not built for vehicle weight loads. Inspect it. Make sure if you have any risers exposed that they're always tight and secure. You don't want anyone inadvertently opening those and falling in. If you have a control panel, have that inspected. Make sure it doesn't have a wasp nest growing in it. So if you need it, you can get to it. Don't put excessive fat, oil, and grease down the drain. That's one of the most problematic things for a wastewater system. It's just, the decomposition of those is not what the septic tank is built for. And do periodic pumping. Know if you need to have annual inspections, and keep your records, and use qualified professionals. Next, please. So we got lots of tools out there. I really appreciate everyone coming and being willing to learn and have this discussion. Thank you very much.
Thank you, Bruce. I know we went a little longer than I had planned for the content, but I didn't want to cut anyone short, because I feel like it was all so good and I learned a lot, and I hope others did too. I would like to there were some good questions and answerings going on in the chat, so thank you for that. But maybe we have time for one question if anyone has a burning question that's coming up. We can allow for that. Let us sit in silence for a moment and see if anyone comes up.
I'm just wondering, is there any other than, because septic system can be expensive, right? Putting in a whole new septic system, and sometimes it's prohibitive, then people, they want to build one unit and add on in the house or whatever, which is what I do. And so so is there any other, like when I sort of question pop up earlier, like in Vermont, is there can people use like compost toilets and gray water flow? I noticed you mentioned the urine distribution. So what falls under legal, so to speak, as alternatives?
Right. We've acknowledged composting toilets can be used, and what they do is they give a percentage reduction. I mean, there's a lot of good information out there about the distribution of sources, dishwashers, washing machines, showers, whatnot. And I think the literature is saying about 25% reduction. Because we've shrunk the flow of toilets so much. You don't get as much water saving as when you had the old 3.5 gallon flush toilet. Now you have like a 1.2 flush toilet. So you get less of a benefit from that composting system. But the 75% of a wastewater system they still have to build has to meet all the criteria. And the reason being is that gray water will still have pathogens in it. If there's anyone that's ill in the household, has a sick, flu or whatever, and diapers, washing or soiled clothes of just a sick person in a washing machine. So basically, we need the pathogen protection for the black water. And I know some states that allow gray water. I use Arizona as an example. Their separation of seasonal high water table for a gray water system is 5 feet, which is greater than we have, our 3 feet, for either a black water or gray water system. So basically, and they have a greater driver. They promote it more out there than we do. But so basically, the answer is yes, but there's limitations.
Thanks.
All right, it is 6 o'clock on the dot, so we will wrap up here. Just want to say a huge thank you to our speakers. Thank you for joining us. This has been a really great series for myself, and I hope everyone else got something out of it as well. Again, we'll be uploading the recordings and slides to our website, and we'll share those out. I added my email to the chat, so feel free to reach out if other thoughts or questions come up, and I'll try to make connections or find answers if I can. So thank you.
Thank you.